right, everybody, I want to thank you all for coming in and participating. Thank you. This is Harold Henry. He is with Hanover Architectural Products. He will be, the topic today is innovative pavers for projects of distinction. I'm already jealous of some of these photos that he's shown, so I'm hoping you will enjoy them as well. Harold, if you want to do any more of an intro, please do. And I'm turning it over. There you go.
Yeah, okay, I will, yes. Well, first of all, this is an AIA and ASLA accredited session. We'll need to get your information so we can see that everybody gets a credit. If you don't have an AIA number, but you're an AIA member, we can still get you a certificate. We'll just need your contact information for that. For, excuse me, for ASLA credit, ASLA requires that you participate in a short quiz at the end of the presentation. So if any of you are looking for ASLA credit, you'll need to be mindful of that and get on the link to take that quiz. Just a little bit of background information on who Hanover is before we get into the meat and potatoes of the presentation. Hanover Architectural Products is a family-owned business. It was founded 50 years ago. The company has very humble beginnings. The founders of the company actually came here from Western Pennsylvania. But when John, the founder, decided that he wanted to start this company and this endeavor, came to Hanover because we're right in the heart of very good aggregate country, which means that we have a lot of diverse aggregates within close proximity to our manufacturing facility, which means that we don't need to transport those over great distances. And as I said, the company has very humble beginnings, just a husband and wife with 2 babies living in a mobile home with a press under a lean-to outside. John would press pavers and load them up in his pickup truck and take them around and sell them to local garden centers. And that's pretty much the origins of the company. Obviously, over the years, we've greatly expanded our manufacturing capability to the point where I feel safe in saying that of all the manufacturers in the country, we are one that has one of the most diverse product lines, covering concrete materials, asphalt materials, concrete materials that can be used on grade, over structure, and even in vertical applications. So our objectives for today, if nothing else, it's my hope that you will have a better understanding of what's being used in the industry, what we see coming down the line with some of the new innovations and new products. We'll spend some time talking about product limitations, and that has primarily to do with using modular unit pavers in a vehicular application. It can be done, but there are some do's and don'ts and some things that we need to pay attention to if we're going to have a successful unit paving installation when it's exposed to vehicular loading. We're going to talk about using pavers over waterproof decks. It's the same material that we're using on grade when it comes to our slab material, but it's just a different way to install it. If you're interested, and I suspect that you probably are because this is becoming a hot button issue in your neck of the woods, about wind uplift, and we'll spend some time talking about that. And we'll also be spending some time talking about various installation alternatives. Now keep in mind, when we're talking about installation alternatives, our primary focus is going to be commercial, institutional, municipal, public access projects. And there's sometimes we need to address that type of an installation a little bit differently than the way we address, for example, residential projects. So hopefully everybody can see my cursor. Hopefully I don't get too crazy with it and make you dizzy. We'll start out with what are referred to in the industry as architectural pavers. We call them pressed pavers. Some of you may remember an older company that's since out of business named Hastings Pavement Company. They called them London Walks. But these are slab pavers, larger format pavers. Our product line would handle pavers as small as 6" by 18 up to 24 inch by 48 inch. That would be the kind of the smallest to the largest. We'll talk about how we would like to see those installed, and again, with that emphasis of public access. Then we'll switch over and talk about using the same material, same product, just a different way to install it, where we're going over normally pedestals to create an amenity space over a waterproof deck. The high wind solutions, we offer basically what we need to know if you have high wind or you're concerned about wind uplift. We need to know what your anticipated uplift pressures are, and then we can compare that to the known values of our pavers. Interlocking concrete pavers, we call ours pressed brick, but it's not a brick, it's a concrete paver in a brick shape. But the term interlocking has more to do with the method of installation than it does the actual shape of the paver. Permeable paving is something that's becoming very popular. Asphalt pavers, some of you may not even know that there is such a thing as an asphalt paver. It's kind of a legacy product. They were first manufactured in the United States by that Hastings Pavement Company that I had mentioned in the late 1800s. That's how far back it goes. We'll talk a little bit about the physical properties of that and where typically we would want to use something like that. And then as time permits, we'll finish up talking about manufactured modular curbing, using the concrete materials in vertical applications. And then we'll finish up with some of the fun stuff that we get involved with, like custom cutting, engraving, things like that. So pavers, slab pavers on grade. This is a concrete material. Concrete is made up of sand, stone, cement, and water. Now, a lot of times people will call me and they'll say, could I get samples of your precast concrete pavers? And that's a bit of a misnomer because it's not precast. Precast would denote cast stone. This product is hydraulically pressed. They're manufactured one at a time. So the way our manufacturing process would involve taking a mix, putting it into a mold, hydraulically pressing that, and within a relatively short period of time, that we have enough strength in that material that we can pick that up out of the mold and stand the material on its side. Now, for coloring the product, there are different things that we can do. We can use different types of cements, white cement, gray cement, or a combination of both, different colored aggregates. And if it's pigmented, many of them do have pigment in them, we use an iron oxide pigment, which we find to be the most color fast. So when that material is produced, that manufacturing process, when it comes out of the mold, what we have on all exposed exterior surfaces is just a cement mass. So in order to reveal that color, we need to do something to the surface of the paver. Options for that would be to blast it. And depending on the mix design, the size of the aggregate that we're using, we can control the intensity of that blast anywhere from light to heavy. Or we can grind it, and then blast it. And each one of those different processes will yield a slightly different color value. You could take a large plaza and use the same paver and then just simply modify the texture that we're putting on it, and you would get a different color value, which would give you a subtle contrast to the pavers. We suggest that if you specify this type of material, that you specify a product that is made from a single mix, meaning that when you look at the surface of the unit, any coloring or aggregate that you see goes the whole way through the unit. There are some manufacturers that will produce their material using a lamination process. And a lot of times what that's telling you is that they don't have that diversity of aggregates within close proximity. They've got to transport it, which makes it more expensive. So in this case, what they would do is take the base and just use that concrete using indigenous aggregates. And then the fancier stuff, which is more expensive, they laminate to the top. What you're giving up here a lot of times is strength. For example, the single mix product at 2-inch thickness will have a flexural strength of 1100 PSI. The laminated product at 2-inch thickness would give you a flexural strength of right around 600 PSI. And that's why if you look at a manufacturer who is doing the lamination process, many times they'll want to see a greater thickness, like maybe 2 1/4 inch or 2 1/2 inch, because thickness equals strength. The thicker it is, the stronger it is. So many times when you see the people who make with the lamination, they'll want to see a thicker product. There's also a potential, because you're laminating the materials together, that you can sometimes see some convex and or concave warp in the material, because you have those two materials coming together and they can react differently with freeze thaw and thermal expansion. There's also a potential with a laminated product that it can delaminate. So here's a project. This was a university in Georgia. Product was in field maybe 6 or 7 years. It's a waterproof deck. There's the waterproofing, there's the insulation, there's the pedestal, and then the pavers. And then this was the fix coming in with a single mix product to make the repairs. So these are the types of strengths that we suggest that you consider specifying. Average minimum compressive strength of 8,500 PSI. Depending on the hardness of the aggregate, you can actually get compressive strengths up as high as 10 or 11,000 PSI. The manufacturing process yields something that is very low in absorption. There's no problem with exposure to freeze thaw. And just to back up that 1100 PSI flexural strength, this is a test. We did this in-house, full disclosure, but we took a 2 foot by 2 foot paver, supported that on all four corners with a pedestal, and then exerted a 1 square inch footprint to the paver to the point of failure. Obviously, the strongest point is going to be directly over the pedestal. The next strongest point will be at the center of the paver, and the weakest point, regardless of whether it's a manufactured unit or a piece of natural stone, the edge of the paver is always going to be the weakest part. But even so, where you can see we're still getting failure loads in excess of that stated 1100 PSI. I guess I didn't say anything about entertaining questions. I would be happy to do that as we're going through this, or if you prefer to wait, you can email me after the presentation. I'll be more than happy to answer your questions, but I think we have a small enough group here that if anybody has any questions, just chime on in. Don't feel bad about interrupting me, but it looks like somebody may have a question here. I see a chat question.
No, that was just me telling people they can put their questions right into the chat box and I'll read them out.
Okay, good. I'm getting ahead of myself here. Okay. Now let's talk about the way that we would prefer to see this material installed. All the components that you see in this detail have to occur in order for us to have a successful unit paving system. Starting from the bottom and working up, we have our compacted subgrade or soil, then our subbase, setting bed, pavers, and edge restraint. All of those components need to occur. The subbase is what's going to give our system its stability and load-bearing capability. Generally speaking, there's 3 options for subbase. One would be a compacted granular subbase. It's usually limestone with a mixture of sizes ranging from about 3/8 inch or 1/2 inch down to screenings and fines. That material needs to be compacted, excuse me, in 2 to 3 inch layers or lifts. For example, if we're using a compacted granular subbase, we would say for a pedestrian application, we would like to see a minimum of 4 to 6 inches of that material used. You don't want your contractor coming in, putting down 6 inches of the stuff, running a tamper over the top, and saying, there, I'm done, because you potentially are not getting full compaction of that material within the body of that. So it should be compacted in 2 to 3 inch layers. The other two options for subbase would be either a bituminous binder course, which is like a base road mix, large aggregate mixed with asphalt. If you've ever seen somebody putting down a new roadway, that's what they'll use for their base. It's generally assumed in the industry that 1 inch of bituminous binder course will give you the same load-bearing capability as 2 inches of compacted granular. And then the third and final option for subbase would be a concrete subbase. If we're using a concrete subbase or a bituminous binder course, we would never put that directly over the soil or the subgrade. We would always want to see a minimum of 4 to 6 inches of that compacted granular material. And that material it's called different things in different regions. In Pennsylvania, we call it 2A modified. In New Jersey, they call it quarry process. You get out to Long Island, they call it crusher run. I'm not sure what you folks call it in Northern Virginia. So if we're using the bituminous setting bed that we're illustrating here, and I'll tell you what we like about the bituminous setting bed. We're of the opinion that if we take a large paver and install that in a sand setting bed, let's say like a 2 foot by 2 foot or a 2 foot by 3 foot paver, we feel that there's long-term potential for eventual movement and migration of that sand under that larger unit. And that would eventually create unevenness in the paved surface, maybe some rocking pavers. And again, remember, I emphasized that our attention here is on commercial projects, municipal, public access material projects. If it's a patio in your backyard and you put pavers in a sand setting bed and sand starts to move around a little bit, so you go out some Saturday morning, pick some pavers up, straighten the sand out, put the pavers back down. But for public access, we don't want to have the liability concerns, nor do we want to have the maintenance concerns. And what we like about the bituminous setting bed, it's still a flexible system. We like flexible, and it's mostly sand because it's proportioned by volume about 93% sand to 7% asphalt. But by just adding that little bit of asphalt to that sand, we've stabilized that system and eliminated the long-term potential for movement and migration of that sand setting bed. If we're using a flexible system like a sand setting bed or a bituminous setting bed, always think of the setting bed as nothing more than the minimum amount of material required to act as a leveling course. That's the only function of the setting bed. Again, all your structural integrity and load-bearing capability is achieved in the base. And as I mentioned earlier, thickness equals strength. So if we're doing if this is a pedestrian application, you'd probably be okay with like 4 to 6 inches of poured in place concrete. For a vehicular application, obviously we need to increase that thickness because that will increase the load-bearing capability. So we've got
Harold.
Say again.
A question for you. How often are the 2-inch weep holes placed?
That's an option. That's not a requirement. The question you need to ask when you're designing this is, am I potentially creating a bathtub? And if you are, then weeps would just be cheap insurance. Now, as far as the weeps go, you could say like every 4 feet on center, or you could just simply locate the low points in the slab before you place the setting bed. You could just find those simply just by throwing some water on it, finding your low spots and drilling your weeps. Any weeps that you would put in that, you would also want to put a layer of filter fabric over that, even if you're using a bituminous setting bed, because it eventually could crumble and you could start losing some of your setting bed into that weep. So there's no requirement. As I said, it's an option, but if we do see people from time to time doing it like 4 feet on center, if they really feel that they're creating a bathtub. So when we're installing the pavers on top of this bituminous setting bed or any type of setting bed, some pavers have spacer tabs on the side and some don't. Usually the larger format pavers do not have the spacer tabs, but it's very important that when we're laying these pavers that we always make sure that we maintain a minimum joint spacing of 1/16 inch and a maximum joint spacing of 1/8 inch. We want that minimum joint spacing because it's never desirable to take two hard materials and put them right up against each other, especially in a flexible system, because they can start rubbing on each other and you'll start seeing chipping on the edges. So we want that minimum 1/16 inch joint, maximum joint spacing of 1/8 inch, because we don't want to open the joints up so wide that we encourage movement of the unit and or washout of the sand between the joints, which is, the sand is something that we would normally use to finish the job after it's done. And then the last component that's required is edge restraint. There's any number of items that you can use for edge restraint. We're illustrating a modular curb here, but there's one thing I like about using a concrete subbase is that in lieu of a curb, we could actually just take a metal angle and anchor that into the concrete base, and that becomes part of the system. Then we never have to worry about any differential vertical movement or heaving of the edge restraint material. The other critical thing with this type of a system is we always want to make sure that we have at least 1/8 inch per foot slope on the paved surface to assure that the majority of the water gets on it will sheet off. You can actually do more. If you can walk on it, you can put pavers on it. You can have more than that 1/8 inch per foot, but the 1/8 inch would be the minimum requirement. The bituminous setting bed material is something that the installer will acquire from a local batch plant. They don't get it from the guys that are mixing this stuff up for I-95. These are smaller batch plants, and they mix the stuff up usually about 2,000 square feet worth of material at a time. The contractor will pick it up at the plant. It's hot. It has to stay hot. Ideally, when you're placing it, it should be somewhere between 300 to 350 degrees so that the material is pliable. If it cools and gets stiff, you're done. You just have to throw it away and start over again. So what the contractor is doing here, they're screeding that setting bed. So they'll bring it in, they dispense it incrementally. Somebody will use a wheelbarrow or maybe a bobcat with a bucket, dump a pile of the stuff here, and then they'll screed that. This will screed harder than a sand setting bed, so they may have to take multiple passes, come back in and shower some low spots and keep going. Now, once we've got that to the proper slope and thickness, and it cools, we can start installing the pavers on top of that. There is another option, though, with a bituminous setting bed, and that is to glue the pavers to the setting bed using a paver mastic. There's two arguments for using paver mastic. One is if we're using a relatively small unit paver and we have concerns about vandalism, by gluing it down to the setting bed, it makes it more difficult to remove the paver. Not impossible, but if somebody wants to pick a paver up, they're going to have to work at it. The other argument for using a paver mastic would be if we're using a small format paver and excuse me, exposing that to vehicular traffic. By gluing that paver to the setting bed, we can help stabilize that paver within the system. The argument against using paver mastic is that if we use a paver mastic, put the paver down, and let's say we want to replace a paver, let's say one got broken or somebody spilled oil on it, we can't get it clean, so we say, okay, just pull that out and put a new paver in. When you pull that paver up, you're probably going to pull some of that bituminous setting bed with it. So you can't go back to that asphalt plant and say, I need 10 square feet worth of bituminous setting bed. You have to buy that in the large batches. But so something would need to be done to replace that bitumen. Something like a cold patch would work that you can get like at Lowe's or Home Depot. Like if you were going to patch your asphalt driveway, that would be a good substitution for any type of patchwork. If a paver mastic is going to be used, there's a couple things we need to talk about. First of all, before a mastic is applied, we want to roll that bituminous setting bed, because after that setting bed has been screeded, there's a lot of loose, gritty sand on top of that setting bed And when we apply the mastic, it's very, very important that it's put on very thin, skim coat, no thicker than a coat of paint. And if we don't roll that bituminous setting bed, as the contractor is troweling that mastic on that, he's going to start picking up that sand, and pretty soon he's just going to have a big gooey mess on his hands. So by rolling the setting bed, we're not so much compressing it as we are tightening the surface up and making it smooth and shiny, kind of like a tabletop, and that will facilitate the application of the paver mastic. And again, if a mastic is used, it's very important that it's put on very thin. If you've ever seen an application where pavers have been laid in a bituminous setting bed and you have that black stuff oozing up between the joints, there's not enough asphalt in that setting bed to make its way up through the joint. It's because the installer used too much mastic. So I always suggest, especially with installations like this, that some verbiage be used in your specification, something to the effect of installer must demonstrate experience working on projects of a similar scope and scale for 5 years or something like that. You don't want a novice coming out here and doing this for the first time. There is a bit of a learning curve. Let them learn on somebody else's job. There are plenty of experienced installers out there that know what they're doing with the bituminous setting bed. Now that I've told you how wonderful flexible setting systems are, we're going to talk about a fully bonded, fully rigid system. The products that we're talking about right now, these slabs, they can be used as pavers, yes, but they can also be used for other applications like pool coping or treads, risers, seat wall caps, things like that. There, we don't have the opportunity of putting some type of edge restraint in place to hold it, so we need to bond it to the substrate. Many times on residential projects, we see people using concrete adhesives, and there's some very good ones on the market. They've made great strides over the years, but normally for commercial projects, we see people looking to mortar. If you are planning on using mortar, we strongly suggest that you use a latex mortar mixed with latex. Years ago, we would go out on projects where we saw our pavers installed just in sand, cement, mortar, and grout. And many times, one of the first things we'd notice would be shrinkage cracks in the grout. And that grout material is usually pretty high in absorption. So let's say we get a couple days of rain, everything is soaked, and then it quits raining, the paver surfaces will dry out pretty quickly. But if it's just a sand cement grout, many times that's going to hold water because of the high absorption of it. If it freezes while that joint is saturated, then those joints are going to pop. In a southern climate where we don't have the freeze thaw, if that joint gets wet and stays wet, you'll eventually start seeing mildew rings around the surface of the paver because that joint is holding the water. By using a latex, we reduce the absorption greatly. For example, there's a company called Laticrete. They tell us that if you use the proper proportion of latex in your grout, you'll get a joint strength of 5,000 PSI with an absorption less than 2%, which is even at a lower absorption than the paver itself. And going back on projects where we've seen the latex used, we're very pleased with what we see in the long term. Also, by using the latex mortar, you increase the strength of the mortar, you increase the bond strength, and also the shear strength of the product. These are just some examples of what can be achieved by using these larger format pavers. Remember what I talked about, color differential, different colored aggregates that can be used, things that can be done in the molding process to simulate a natural stone, different admixtures that can be added. Here's one that's using a seashell in the paver. Detectable warning pavers, if you folks are getting out in public, I'm sure you're seeing those all over the place. And this seems to be the latest craze for the pavers, the long linear pavers. Okay, Does anybody have any questions about on-grade installations? We're going to switch over now to talking about using these pavers over waterproof decks. If you don't have anything pops up later on, feel free to reach out to me. I guess the best way would be to do it via email. So this is the only detail that we show in our brochure where it comes to pavers on pedestals, but this is what we see most commonly used in new commercial construction. It's called Irma, inverted roof membrane assembly, where we have a waterproof deck, structural slab, waterproofing, and then insulation. And in this case, the insulation is serving two functions. Number one, it's serving as a protection course for the waterproofing, and it's also providing the required R value. If we're building the system this way, it's very important that the insulation is extruded polystyrene, and it must have a minimum compressive strength of 60 psi. Anything lower than that, we can see under heavy loading, the potential of the pedestal shearing into the pedestal, or maybe some movement in the pedestal. For example, you can actually get 60 psi expanded polystyrene, and we learned on a project that we did in New Jersey years ago, the architect specified 60 psi insulation, but did not specify extruded polystyrene. So the contractor used expanded polystyrene, put the pavers on the pedestals, and it was a beautiful looking job. But when you walked on the pavers, they would just depress ever so slightly as you walked on them. What turns out that expanded polystyrene at 60 psi can deflect as much as 1/4 of an inch. You don't get that deflection with the extruded. So it's very important that you specify extruded. Now, this type of system has gone over virtually every type of waterproof membrane configuration there is. Maybe you don't need insulation. Maybe you're going over a parking garage or something like that, and you don't need insulation to achieve a specific R value. The only constant you'll find, though, is that most, if not all, membrane manufacturers will require some type of a protection course to occur between the waterproofing and the paving system, which is the pavers and the pedestals. So you would need to consult with the membrane manufacturer and find out what, if anything, they require as a protection course for that membrane. These are just some different types of pedestals that can be used. This pedestal, this rubber pedestal, is very inexpensive, but you don't have any leveling capability with it. So if you had a deck where you just wanted to elevate the body of the paver and allow that paver to follow the slope of the deck, that would be a good option. If you want to achieve a level paved surface, then we need to move into a different type of pedestal. Here, this is a fixed height pedestal, but it's stackable. We can stack them one on top of another, and we can get fine adjustment by shimming with either an 1/8 inch or a 1/16 inch shim. Those can be actually stacked quite high, but with the recent introduction of using threaded cylinders as pedestals, once we get to the starting height for the threaded pedestal, it makes more sense to switch over to that from a cost standpoint, and material cost standpoint, and from a labor standpoint. Once we get up to that minimum height, it makes more sense to switch over to that. If let's say we have a deck that's sloping at 1/4 inch per foot, and we're building the pedestals up 10 inches high, and we want to create a level paved surface, we need to do something to level that pedestal out to assure that we get full contact or close to full contact of the paver on top of that pedestal. So this is something that can be used underneath the pedestal to compensate for that slope, and that then gives us a level base or close to level base upon which we can start building our pedestals to the required height. It doesn't happen a lot, but there are times when people are putting pavers on pedestals. Ideally, we would like to see some type of structural edge restraint around the entire perimeter, like a parapet or a building wall or planter wall, something like that. Sometimes we see it done where the pavers are just kind of hanging out there. If that's the case, steps need to be taken to restrain that end paver to keep everything from eventually just creeping and sliding off of the pedestals. So this device can be used for that. That would constitute your edge restraint with the edge on the device, but that isn't real substantial. So if we use that, then we need to go back 2 courses and either mechanically strap the pavers together or at least glue them 2 courses back. There's details on my website that illustrate that if you're interested. Some of these smaller pavers that we talked about can't be used with pedestals because there's not enough room underneath that paver to get a pedestal at each corner. So a grid can be used, supported on pedestals, and then the pavers can be laid on top of that in the pattern desired. Excuse me. So with this type of a system, if we're using a modular unit paver that is fabricated to close tolerances for length, width, and thickness, there are 3 very realistic expectations. Number 1, when you stand on one end of the deck and look across, it's a reasonable expectation to see a perfectly straight joint line. Number 2 is we should have minimal, if any, unit to unit offset or lippage between the pavers. And the big one is that when we're walking on those pavers, they should not move or rock underfoot. So if you're up there going through your punch list and you've got rocking pavers and the installer says, hey, this is as good as it gets, don't accept that. It's just a matter of picking pavers up and properly shimming those to take care of those issues. When we're putting pavers on pedestals, it's usually not desirable to have tiny slivers sitting on a pedestal because it's not going to be real stable. So one of the things that we can do to address that would be to use oversized pavers. So let's say we're using a 2 foot by 2 foot paver here in the field. Along the perimeter, we can provide a larger paver like a 2 foot by 3 foot. It's an option, not a requirement, but we could actually score a false joint in that at time of production. And then the contractor would just simply trim the paver beyond that score mark. And even though it then would look like a small sliver, in actuality, it's attached to a larger piece. You can address this in your specification, saying something like no paver less than, let's say, 6 inches wide on pedestals. Oversized pavers may be required. Installer to collaborate with manufacturer. And we do this all the time. Once we have a contractor on board, they can send us drawings. We can help them with layout and also a suggestion on how many oversized pavers, if any, would be needed. With green roofs, there's always a requirement to have some kind of termination between the paving and the plant material. One option would be to use a modular curbing, and we'll have a couple other shots of that coming up in a little bit. And if you're looking for lead credits, we can provide you with the SRI values of the different colors that you could use in order to get lead credits. And here's an example of where we would use a curb, manufactured curb, between the plant material and the pavers. When the curb needs to be laid up with an open joint. Remember what I said about taking 2 hard materials and putting right up against each other. And these are big, heavy honking pieces of concrete. So if you've got them right up against each other, if you get any movement, you'll start seeing chipping on the edges. So we want to have an open joint. And that means then that we're going to need to tuck filter fabric in behind that to keep your medium from washing through the open joint. There are options. These are details we have on our website as well, where the curb can be glued together and or doweled together as well. Okay, uplift. It does happen. We've seen it happen. And what we need to know on a project, if you're getting involved in design, if you could tell us what your anticipated uplifts are, and then we can compare that to the known values of the pavers. For example, a 2-inch thick paver weighs 25 pounds per square foot. A 4-inch thick paver weighs 50 pounds per square foot. And we have the weights for in between thicknesses like 2.5 and 3 inch. So hopefully those weights would satisfy your requirements for uplift. If our uplift requirements are greater than that, then you could go with a paving system where everything is locked down. The one that we make has been tested to provide uplift resistance up to a negative 81 pounds per square foot. Now, if we're above that, we need to sit down and talk about it. Maybe we need to look at other options for that. But normally, if we're usually good up to that negative 81. This is an option for a loose laid paver that will provide, again, for wind uplift. It's a kind of a specialty material. It would not be intended for use on a plaza deck or an amenity space. Ideally, it would just simply be used as ballast and protection for your waterproofing. A typical application for this would be, let's say if somebody's building a big warehouse and has just this big massive roof, this could be laid, and that will provide, that's been tested with wind speeds up to 130 mile per hour with no movement, with or without a parapet. Okay, interlocking pavers. Remember, I mentioned before that the term interlocking has more to do with the method of installation than it does the actual shape of the unit. This is a slightly different animal than the hydraulically pressed material that we already talked about. These are smaller format pavers, and usually what you're finding is that the aggregate size is going to be reduced. So, for example, if you saw one of my pavers, from the slab format and liked the color, but wanted to specify it in a smaller unit, chances are that's been converted, but we would suggest that you request a sample just because there are going to be some differences basically with the size of the aggregate and possibly the texture. Now, though these types of pavers can be installed the same way that we've already talked about. They can go in a bituminous setting bed. They can go in a latex mortar setting bed, but more frequently, we see them installed over a compacted granular base and a sand setting bed. Remember what I said before about the setting bed. It's always just the minimum amount of material required to act as a leveling course. The load-bearing capability is achieved in the base. With the type of sand, we want to make sure that we use a sand that conforms to ASTM C33. Some people call that concrete sand. We want to use this as opposed to a C144, which is a masonry sand. It's a real fine powdery sand. This is a sharp, coarse, angular sand, and we rely on the nature of that product to help us to achieve the interlock. Remember what we saw before with the detail, same concept, we're just drawing it a little bit differently. We've got the same components, sub-base, whoops, too quick on my trigger finger. Sub-base, setting bed, pavers, edge restraint. All those components have to occur. Here we see the base material being compacted. Again, that's that crushed stone with a mixture of sizes, needs to be compacted in 2 to 3 inch layers. Here we see them screeding the setting bed, and these are control bars. There's one on either side. Those have been shimmed to the proper height and slope, and they'll just pull that sand, and that's going to screed or pull a whole lot easier than the bituminous setting bed. After that's been screeded, they'll carefully slide those control bars out. Now that's going to leave a depression, so somebody will walk in there with a shovel full of stuff They'll take a tiny little board, they call it a loot bar, and fill that in. And after that's been done, we don't do anything else to the sand setting bed. It's ready to receive the pavers. And after a sufficient number of pavers have been laid, a vibratory plate compactor can be passed over the pavers. It's always advisable if we're using a plate tamper that the contractor use like a neoprene pad. I've even seen people take pieces of carpet and use that as a cushion so we don't scratch or mar the surface of the pavers. But that will push that paver down into that setting bed. After that's done, more of that sand is spread over the surface of the pavers. And if you ever get an and then the vibratory plate compactor is taken on multiple passes. If you ever have an opportunity to see it, it looks like that joint is sucking that sand. And what we're doing is we're packing that joint. These pavers all have spacer tabs on the side, so it's easy to lay those up with a uniform joint spacing. We're packing that joint tight with that coarse angular sand, and that's creating friction between the pavers. And at some point, those pavers are going to lock in tight. And that's primarily what the term interlocking means. Now, when it comes to using a modular unit paver in a vehicular application, there's a couple things we need to be concerned about. Number one, we need to make sure that we use a paver that is small enough, yet thick enough that it can move under the load without fracturing. Generally speaking, in the industry, you're okay in that regard up to a 12-inch by 12-inch paver, 3 inches thick. That paver is still small enough and thick enough that it can move under the load without fracturing. The other thing we need to be concerned about, though, is how that paver is going to perform within the system relative to the various horizontal stresses that are applied to it. Our preferred method would be to use a rectangular paver in a herringbone pattern, because if you can envision a herringbone pattern and stress applied from any given direction, that stress is going to be distributed among the greatest, or shared among the greatest number of pavers, as opposed to what we would consider to be a worst case, a stacked bond pattern. Imagine that car coming in there 15 times a day at 15 miles an hour and slamming on its brakes. All that stress is going to go straight down the line. And it's usually conceivable that over a given time, you'll start seeing the joints you'll get like a little umbrella shape out of it where because of the force of the pavers going in it. So this would be the preferred method, especially in high use, heavy access vehicular loading. Now, with respect to a square paver, if we have a lot of turning, we've seen 12 by 12s, even something down as small as a 6-inch by 6-inch, where there's a lot of turning involved. There can be torque applied to those pavers and they can start to twist. If they start to twist, the corners can come in contact with one another, and it's a flexible system, so they'll start rubbing, and you'll start seeing chipping on the corners of the paver. Now, I like to tell people there's vehicular and then there's real vehicular loading. I mean, if we're talking about somebody's residential driveway, just an automobile in and out, not so much of a big deal. But if we're talking about a crosswalk on a city street, something like that, I think we need to load for bear and make sure that we build it this way. We'll go through this one very quickly. There's just some different types of these smaller format pavers. Okay, permeable paving. There's two options that we have when it comes to permeable paving. You can get a permeable material like permeable asphalt or permeable concrete, and that's normally a product that doesn't have quite as large a concentration of aggregates in it, and the water can flow through it. The other option, what we're showing here, is this paver. The material itself is not permeable, but it's laid up in a system with a wider express joint, and we can actually create a level paved surface. We don't need to be worried about sloping this. We can actually make it level if we want, because we want to encourage the water to get into the system. Remember what we talked about before when we were talking about installation details. This is slightly different. The concept here is that we're using aggregate base, but we're using open graded aggregate. And what we mean by open graded, there's no fines. So we build up a base. Our bottom course is made up of very large open graded aggregate. Then we have another layer of open graded aggregate again, which is slightly smaller, but it's still large enough that we can place it over that base course, but it's choked. So we don't have to be concerned about that migrating into that base. Then we do one more layer, again, slightly smaller, but it's still choked. And that becomes our leveling course and our joint filler. In our opinion, this type of a system can handle about 6 to 8 inches of rainfall per hour. But then you're going to have to decide on what you're going to do with the water once it gets in there. Are you going to hold it? Are you going to detain it? Are you going to retain it? Or are you going to allow it to slowly exfiltrate from the system? So there's different options that you have with that. Okay, asphalt pavers. As I mentioned earlier, asphalt pavers, kind of a legacy product, first manufactured in the United States in the late 1800s. These are smaller format pavers. The largest that we make would be like a 6-inch by 12-inch unit. And we're always working with a black asphalt binder. So the way that we achieve the color in this is with the aggregate. And it's normal for this material when you're looking at those and they look relatively dark. After they've been down for a while and exposed to UV, that black asphalt binder will eventually gray out. Some people call it oxidizing, and then the aggregate becomes more prominent in the unit. Asphalt pavers are used or have been used most frequently in projects that have very high concentrations of pedestrian traffic, because it offers itself as a softer, quieter walking surface. These pavers have to go in a bituminous setting bed. Some of the older folks still refer to the bituminous setting bed as the Hastings method, because Hastings developed this setting bed to be used with their asphalt pavers. We just talked about interlocking pavers. It's the nature of an asphalt paver that if we try to achieve interlock with that by using that coarse angular sand between the pavers, it's just the nature of the asphalt material that sand won't grab the side of the asphalt paver like it would a concrete paver. So these have to go in a bituminous setting bed. So as I mentioned before, this is a project that surrounds an entire city in Indianapolis, the Indianapolis Cultural Trail, but it lends itself as a softer, quieter walking surface. As a testimony to the asphalt pavers, it can also be used for industrial flooring. Let's say you have a factory and you pour a concrete floor. Well, you don't want to beat that up with forklifts and everything. So you pour the concrete and then you install a wearing course over that. Historically, a lot of people use the old creosote wood blocks, but there's a problem with that with humidity and water leaks where the wood blocks could get saturated with water, just expand and just blow up, where we don't have that issue with the asphalt pavers. But people can take that and, like Alcoa Aluminum, for example, uses these on their industrial floors and run heavy forklifts over them all day long. The issue is that the concept was, again, we put the wearing course down, wear that out, and then tear that up and replace it with a new wearing course. The issue is it's kind of like the 100-year light bulb. Nobody ever wears them out. Modular curbing. This is brought to the market normally as a less expensive alternative to natural stone curbing like limestone or granite. It's not meant to compete with poured in place curbing. This is a molded product. There are some radius dimensions available, but we're limited to the radius dimensions of the molds that we have. So for example, you could go to a granite quarry and say, I need a 2 foot 11 and 13/16 inside radius, and they can cut that for you. But with this, you're going to be limited to just the mold shapes. Okay, here's examples of where this concrete material can be used in vertical applications. And there's two options. One, it can be made relatively thin, like 1.5 up to 3 inches, but it can be fabricated with a groove so that we could hang that, just like if you're using granite or limestone and you wanted to hang that on the side of the building, that's how you would do that. The other option would be to make it thicker, like a masonry unit, 3 5/8 inches, and just lay that up using standard masonry practices. And not only can the flat pieces be done, but there's also an option for sills and water tables as well. Oh, my timing is impeccable. And we'll just finish up then with talking about options for what can be done, specialty options with specialty cutting or engraving on the material. We saw some shots earlier I think you did, Lauren. I think I got out of it before, but this is one of the new things to hit the market is porcelain pavers. It's an actual fired porcelain material. It can be used on grade, can also be installed on pedestals. Specialty cutting can be used. Water jet cutting is something that's used by quite a few people today. In the past, everything had to be cut with a saw, so that just meant linear cuts. But there really isn't any limitation to what you can do with water jet, as you can see here. And engraving, again, involved in projects many people do, where you have a university or a public entity like a park or something like that, where people are looking to raise donor dollars. This is a piece of polished granite that has been engraved. And that's everything I have. I hope I was able to convey some good information to you. Get that list to me. Oh, I failed to mention, you don't have to remind me, Lauren. Again, as far as the credit goes, here's your links. ASLA is going to require you to take a quiz. For the AIA information, we just need to get your name, email address, your ASLA number if you have one, and we can see that you get the necessary credit.
Yeah, the forms were also sent out on the reminder email that I sent you guys yesterday, late yesterday evening. So if you could, now that you have completed it, take this.
Harold, you have another question here.
Oh,
When the pavers are water jet cut, how are the pieces provided to the site for the installer?
I'm sorry, how are the what?
When the pavers are water jet cut, how are the pieces provided to the site for the installer?
They would be packaged, and normally, if you've got something that's real intricate, we would probably take them and number them and send a legend along showing how it goes together, and then package the pieces and probably number them so that the installer could identify them. Was that the question?
I think yes. She says yes.
Okay. Yeah, we wouldn't just throw everything together and throw it out there and say, have at it. We would identify the pieces. There's also, if something gets real intricate, like a compass rose or something like that, there's a company that we partner with in New Jersey. I guess I can say the name now that we're not in the presentation. The company is called Paver Art. And we partner with them on a lot of projects where we like to do what we do best. And sometimes when you get something that's really, really involved, we turn it over to them. A good example was a project that we did in Holland, Michigan a number of years ago, where we had the wooden shoes and the tulips and all that stuff. And he just did the whole thing, put it all together, put a little instruction sheet and shipped it out. So all the contractor had to do was look at the sheet and get the pieces. So we wouldn't leave you hanging, I guess is what I'm saying.
Yeah, I don't think anyone wants to be left hanging, that's for sure. Any other questions? Last shot, everybody. You've got lots of thank yous and wonderful and very informatives in there, Harold. So.
Great, I appreciate that. Feel free to get in touch with me if you think of any questions later on. But I really appreciate the opportunity. As you know, with these lousy times, I'm actually giving 2 presentations in person next month in Boston. That'll be the first in what, 2.5 years that I've actually stood in front of a group of people. So, so hopefully things will loosen up.
Okay, excellent. We're hoping for that as well, let me tell you.
Yes.
All right, well, it seems as if the questions are over. So I thank you for your time. And Harold, if you would stay on for a little bit, I just have one other question for you.
Okay.
You know what, actually, I'll call you up on the phone, and this way we don't have to keep everybody on.
Okay.
Thanks, everybody, and have a great day. Thanks, Harold.
Thanks, folks.
Bye-bye.